Review for Pre-Calculus Chapter 4 test, last page. Find the exact value of the inverse cosine of -1/2. So first we need to use our 30, 60, 90 right triangle. The cosine is always the adjacent over the hypotenuse. So the adjacent over the hypotenuse would refer to a 60-degree angle. So that is my reference angle. Then I have to figure out whether I am in quadrant 1 or 2. The inverse cosine, I'm restricted to those two quadrants. Since this is negative, I must be in quadrant 2 because everything is positive in quadrant 1. So this is negative, quadrant 2. So my reference angle is 60 degrees. That means I did a turn of 120 degrees to get to that point. So 120 degrees would be the answer, but when they ask you for exact value, they're going to want it in radians. So convert to radians the same way we always do by multiplying by pi over 180 degrees and then reducing to lowest terms. And your answer is 2 pi over 3 radians. Problem 22, find the exact value of the inverse tangent of 1. So the inverse tangent is limited to quadrants 1 and 4. Because this is positive, that means I'm in quadrant 1. And I'm not going to use the 30, 60, 90 because I'd never be able to get 1 with that. So I'm going to use the 45, 45, 90 triangle, which is isosceles. This is 1, this is 1, this is the square root of 2. So the tangent is TOA, opposite over adjacent is 1. So it's going to be 45 degrees. Convert 45 degrees into radians by multiplying by pi over 180 and reducing to lowest terms, and we get pi over 4 radians. Find the exact value of the cosine of the inverse cosine of 0.65. As long as this is between -1 and 1, then that will be your answer because these will cancel each other out. An object in simple harmonic motion has a frequency of 1/2 oscillation per minute and an amplitude of 7 feet. You want to write an equation of the form D equals A times the sine of omega times t for the object's simple harmonic motion. So all you have to do is plug in the amplitude here, and then you have to make an adjustment for the period. If they're giving you the frequency of 1/2 oscillation per minute, then the frequency is equal to omega over 2 pi. So set the frequency that they give you equal to omega over 2 pi, and then you can cross multiply, and that will give you 2 times omega equals 2 times pi. Solving for omega, divide by 2. And that's how I get omega is equal to pi. And so that becomes the coefficient of t. From a point on the ground, 28 yards from the base of a building, the angle of elevation is 36.2 degrees. Approximate the height of the tower to the nearest foot. So first draw a picture. Here's your angle of elevation, 36.2 degrees. 28 yards from the base of a building, we want to estimate the height of the building, so we're going to want to use tangent. The tangent of this angle is the opposite over the adjacent. So set that up. Make sure you are in mode degrees in your calculator, very important or it won't come out right. To solve for x, you just have to multiply by 28. So you can do this all in one step in your calculator as long as you are in mode degrees. 28 times the tangent of 36.2 degrees. You get this, round it to the nearest foot because it said nearest foot, so about 20 feet. And the last problem, find the exact value of the cosine of the inverse tangent of 5/12. So we want to set up a right triangle. Name one of the angles theta. It doesn't matter which one, as long as you're setting up so that the tangent is 5/12. And the tangent of this angle would be the opposite over the adjacent. So the opposite over the adjacent should be 5/12. Use the Pythagorean theorem to get 13. So 5 squared plus 12 squared equals c squared. That's 25 plus 144. That's 169 is c squared, and the square root of 169 is 13. So that's how I get the hypotenuse. So we've taken care of this, and now we want to find the cosine. So the cosine would be the adjacent over the hypotenuse. So 12/13 is the exact value.